I hope in this talk today that some of the ways that I've been exploring and researching how to embrace creativity in our teaching and assessment of sort of key statistical ideas, that some of that might be useful and helpful as we navigate future paths in times of uncertainty at the moment. So if you haven't been to a talk of mine before, it may be a surprise, but for others it won't be. What I want you to do for me is head along to a particular little app I've set up that we're going to use throughout this talk. I'm just going to quickly put it into the chat as well. Of course, it's not too long. It's the bit.ly one there, but I'll just put it in here for you as well. If you open that up, it's just going to show you that same little stats cat meme, which is my sort of filler. And I'll just give you a chance to open that up. And then what you can do for me just to check we're sort of in the same zone is in the chat for the Zoom, if you can put like a smiley face or a thumbs up or something in the chat just to let me know that you're in there at this point, just as a bit of a sign. So I won't always use it, but throughout the talk, I might. Obviously, you can still use the chat for other things that come up. But you'll see there's some things that we can do in this app that we can't do in the chat, so that's why I've set it up. Okay, looking pretty good. Okay, so we're going to start with a question. So at the moment, when you look at the app, it's just got the cat. If I kind of use the app, I'll say refresh the app, which is referring to this little yellow button that will sit at the top left-hand corner of the screen. And when you refresh that, whatever I've loaded up for you next will appear. So I'm just going to change that now. If you press refresh app for me now, then you should be seeing a writing box, hopefully. I'm just going to quickly load it up so I can see what you see as well. And then what I'm after from you is imagine that you're a student and you're at high school level, and you ask them, what subject do you think at high school is the most creative? So think of it from a student's perspective. All I want you to do is add in quickly what subject you think they would say is the most creative. And if you want to, you can say why. Why would they think it's the most creative subject? So if you've noticed that the app has got quick, right? So the idea is don't think too much about it. Just what comes to mind. Just chuck it in. And it's completely anonymous. So if you're worried that maybe I'm tracking you somehow secretly behind the scenes, I'm not at all. So you can go with it. All right. So I'm just going to pull it over really quickly. So here's what we've got so far. And I kind of was hoping, because of my next activity, that the kind of like quick kind of like feedback would be all art, something where like as an artist, right? Like you're making something, you're painting, you're doing photography, maybe drama, maybe dance, because they're artists as well, right? And it's this idea that that's what we think of when we think of creativity, right? Is this kind of artistic expression. Okay, that's cool. Well, let's try it out then. So I'm going to ask you to draw something in a moment, and I'm going to switch the app over, and this is going to allow you to use your mouse, or if you've got a touchpad, to draw something for me. And let's have a look. Let's have a look at how creative we are as well. So if you refresh the app now, so I'm going to pull it over and show you what I mean as well, just for those people who are watching on this recording later. If you refresh it here, you're now going to have in a moment it will load, you're going to have a space here. So you don't submit it yet, but you can have a go at drawing something, right? And then clear it, no? Right. Here we go. So what I would like you to do for me is I would like you to draw for me data. Just whatever comes to mind, draw for me. What comes to mind when I say the word data? I'll give you a little bit longer, although I'm not after any sort of amazingly sort of like, Picasso level artistic expressions at all. Pretty cool. Okay, so again, just for the sake of expediency and because I have a terrible habit of planning way too much for any of my talks, here are some of your initial examples of things that you came to mind and that you expressed through drawings of data, right? And so again, so we can think of creativity as drawing. And one way that we can use these drawings creatively is that they are data themselves, right? We can think about creating variables from how these different things have been drawn, how these different kind of ideas of what that looks like, tables of data, maybe representations or graphs of tables, cats. I don't know if that's just someone appealing to, or we're counting cats. Either way, I'm down with the cats. Thank you very much. But there's also, the data that's being captured as you drew those drawings as well. And so behind the scenes, what we have here is data to do with what device type you had, your screen width, where you are in the country. These are all the points that were made as you were dragging your finger or cursor across the page. How many strokes, how many times you kind of took your finger off, how long it took you to make that drawing, and that's just a random user ID, right? So you might think, well, I'm going to do a talk about this. I've done talks about this before. I do think it's a pretty cool way to be creative in terms of teaching stats, is to look at things like drawings and text and images as well. But that's not the only way that we can think of creativity, right? Here are some drawings from my second stage students. I had them as a backup. You never know with technology, right? It might not work. So these are my students. And I thought they really enjoyed the activity in terms of, showing me what they thought of data. This is maybe the first or second lecture of the course. And then the next lecture, I came back and at the beginning of every lecture, they're allowed to ask questions or write comments before we start. And they were students are like, please don't make us draw anything. And actually, I didn't make them draw anything else in the entire rest of the semester, not because they said that, but just because I didn't end up using anything that was drawing based. So yes, drawing would be a cool way to explore creativity in stats, but it's not the only way. So if we think across the current statistics NCA standards that we have right now, and you had to pick one that you thought was the one that the most currently embraces and supports creativity, if any, which one do you think and why? So I've flicked the app back to writing, so you'll have to refresh the app at the top, and I'll give you back the writing space. And again, this is anonymous, right? But which one of the standards? So we're thinking at year 11, year 12, year 13. If you're not super familiar with the NCA standards, maybe you could think of a topic where you think that this is a topic where you really feel that students get to be creative when they're working on tasks in this area. So I'm laughing because I can see your answers appear on another screen that you can't see. And so, when you plan something and you're hoping, you've got this implicit model of what you think people might do, what your students might do in response to something. And then when it comes out that way, you're like, yes. Okay, so let me pull it over. Again, I'm sorry if the pace of these sort of little activities, but here we go. So for the most part, we're looking at ones that are coming from statistics, right? And if we scroll down here, we're looking at experiments pops out, most of these responses here. And I would say that I kind of agree as well. And when you think about what it is, well, maybe you feel the same way, but for me, it's because I feel like you know, when the students start, there's no data, it doesn't exist, and they get to design kind of the conditions, design kind of the situations and what they want to change, you know, for their like treatment variable, and it engages them in the whole process of creating and then using that data themselves. So what we want to do is think of, well, how could we maybe try and embrace more of that in our teaching and assessment of probability modeling, right? Because I really do care a lot about creativity, almost to the point where I'm a little bit kind of, people talk about being on the fringe of things, but I really kind of almost care more about that than most things at the moment. Knowing stuff is really important. You know, no one's arguing about not teaching knowledge and teaching like methods and ideas and concepts that are really important. But, you know, in the world we live in right now, like knowledge by itself is not enough. The robots aren't just coming, they're already here, like they're here. And we talk a lot about what are we going to do about these large language models or generative AI, and we have to adapt our pedagogies and our teaching. We absolutely. I love technology, I embrace it. But at the same time, we have to think as quickly and as rapidly about ourselves as humans and what our thinking skills need to be to function in this world, right? And deal with unexpected events. What I've been really digging into is this idea of selective combining, and what does it mean to do this in creative ways? So it's the idea of how do we think creatively, but also how do we create useful things? And although I'm still involved with the very large intro stats courses, a lot of my work now is in the data science sort of courses. We're focusing really on data and technologies. So one of the courses that I'm involved with is a second stage course. It's called Stats 220. It's about data technologies. And the reason we have this course is because when we think about being a statistician or a data scientist, it's not just about analyzing data. You know, the data that we work with is, it's not just about kind of creating, doing hypothesis tests or writing interpretations of these methods. We're going to have to think more about the data itself, the kind of ways that we use it, so a lot of computational stuff, but also that we need to better think creatively. We have so many options and possibilities and potentials for not just the nature of data we have, but also the tools that we can use. And if we don't focus on the act of how to create, then our students moving into the world that we're in, they're not going to have those necessary skills. So, you know, it's all about people. It's all about connections. It's all about our students. And a focus on creativity is also a focus on humans. It's a focus on us as individuals, and having space and options to make stronger connections to our data, to value really important things. Tairanga kōrero and te hononga. These are two of the big ideas from the current learning matrix for mathematics and statistics, and they're really important. And it's not just words on a document, right? How do we bring this into the classroom, and how do we make this sort of a lived experience and opportunities for our students as well? So how do we do this within our probability and modeling? Well, as it says here, through exploration, through discovery, through conjectures, through connections, right? Looking at observations, thinking about what we know, what we don't know, thinking about processes and pulling those together. And from that, coming out with a deeper understanding and confidence with what we're doing. So these are the three areas that I focus on in this particular course. It is obviously a focus on data technologies, but what I want to stress here is that it is a focus on creativity, it's a focus on communication, but at the core of it is a focus on knowledge, right? So yes, knowledge is important. It's going to be a key thread through what we do, but we have to sort of like surround this. And at the same time as we're opening up more knowledge, we have to open up more kind of ways to be creative and to be able to communicate at the same time. And the types of activities that we think about using and doing with students. For me, I think about my tasks a lot differently now. And to be fair, I have an advantage, right? I'm working in a different system. I'm not constrained by every assessment system has constraints. I have less constraints. than if I was still working in a classroom at school level. But one thing in particular that I really want is I want my activities to be about learning, to promote creative thinking, and I really want to reward growth and perseverance, not just sort of technical competence. So one way I think we can do this is through data sources and choices. They don't quite rhyme, but they're kind of close enough. So if you were at NZAMT last year, I did a little bit of a talk around this idea of using data landscapes. This idea is that you have a kind of core task that has some sort of common motivation and some sort of common destination. So we're thinking about a task being a learning journey. But what we want to look at is how can we have students or give students opportunities to customize their learning journey by choosing their own backdrop, right, their own data landscape. And what this means is when we're thinking about developing our tasks is we're trying to pull out what's sort of the minimal structure that we need. And then we want to maximize the experiences of using that structure across a kind of a variety of different data landscapes. And we can totally do this with probability modeling as well. So this is a question from last year's level 3 probability distributions external exam. It involves modeling the amount of nitrogen fertilizer being used on New Zealand dairy farms. And this is a pretty typical kinds of activity, right, or question that we might come across. So how can we embrace creativity in this? And first of all, I want to say that I'm not saying that this is not creative by itself at all. And I think whenever people who write exams, I think they're probably one of the most creative people that we have in terms of how hard it is to develop assessment tasks. But if we look at kind of the minimal structure side of things, what's sitting behind this sort of probability modeling activity? Well, this is a simple framework I developed as part of my master's research project when I was specifically exploring teachers using probability distributions. And how this framework works is we know that we're observing something that's coming from a true data generating process, in this case, the nitrogen fertilizer. And it's been applied per hectare per year on the dairy farms in Aotearoa. And what we're thinking about is, well, what kind of probability distribution might be a good model for this, right? We know that this is just a model, it's not the true way that the data is being generated. And we know that one thing that might help us out is analyzing the situation itself and thinking about its characteristics and thinking about different features of probability distributions, whether they match or not. But also what might help us out is to generate data from this model and see what it looks like, and then compare that to what we've got and see how similar they are, right? But that's a very minimal structure for what we're doing for this task. So how can we make it kind of more creative and more personal? Wow, again, if you were at my talk last year at Stats Teachers Day, one thing I focused on was, well, we could turn this into an activity where we're trying to make a monster who blinks like a human, right? So there were a bunch of different monsters. I'm not going to repeat that activity now, but they're all being modeled in different ways, right? And some of them you might think appear more human-like than others. But the task itself is really, it's all about the data landscape, about that data source, and very minimally about the structure or the task itself. It really is this: I need some help. I'm a monster. I will look like a human. Go get, go work out what kind of mechanism, what kind of model might make sense to help me look more human. Okay, so what we need is a data source, right? We need a data source. We need something that we can watch and record data from, and then use this as a part of our modeling process. So let's do this. I want you to spend a little bit of time right now. Head to YouTube. YouTube's a pretty good source for this. See if you, and I'm really interested in what your strategy for this as well. See if you can find what you think might be a good YouTube video to use for collecting data on iBlink. So I'll just give you a few minutes. Go into YouTube, think about what search terms you might want to use, or maybe you already have an idea of like who or what might be a good thing to get a YouTube video on. And then again, in our sort of my Slinky app, what you can do is come back and you can maybe paste in maybe a video that you found. And you could, if you wanted to, also explain why do you think it's a good video. Okay. Have we found much luck? I don't have any coming through. Maybe it's difficult to find a good video. Oh, we've got one. Let's try it. We've got one. Somebody's offered up one. Let me just grab that. Let's have a look. So what are we going to get?
With Woolworths Online, you can...
Oh.
Hello? Mandy, what are you doing here? What am I doing here? Where is here?
Bless. Okay, very cool. So that is an example of, and that one's got excessive, that one says excessive blinking as the name of that YouTube video. Yeah. So this process of trying to find a good data source is obviously a creative process, right? And there's billions and billions of videos on YouTube, and so it's not easy. It's not like a simple thing. You can't just go there and find one. You've got to spend some time, and you've got to spend some time reviewing what you find, and thinking about what is it that you're looking for, what kind of characteristics would make this a good source of data for this particular purpose of trying to model eye blinks. So I'm really fortunate that I have had a chance to work on this particular task with the multiple blinks with students at Cashmere High School for a few years now. And so every year around about this time, year 13 students, they work with Michelle and Amy and others in their scholarship stats program, have a go at kind of doing this task. And what that's allowed me to do is kind of try out a different way of looking at when they do this kind of activity where they're trying to find a model for eye blinks, what kind of ways could we look at sort of assessing it, right? And so I presented these ideas last year as well, but what I've really kind of honed in on, and you can see these are the same 3 threads that I showed you for my course for Stats 220 as well, which is to focus on creativity. So I'm looking at what the students are producing in response to that task. How creative are they? So are they exploring different ways to create things? They're open to ideas, they're trying out different things. When it comes to knowledge, it's not just knowledge itself, but it's also critically considering it. So there are different knowledges that you could consider. You want to question them, you want to evaluate them, and you want to be challenging ideas as well. And of course, there's the component, which is the communication side of things as well. How clearly or cohesively, convincingly are these ideas being put forward? And there's a 4th part here, which is that I really wish we also could ask students to reflect on their learning journey, not to reflect on the use of the inquiry process, that's important too, but them as learners. What is something that you found interesting? What did you find really surprising or kind of like new statistically? And what does this make you more curious about the world? And I've been doing this consistently for sort of 8 semesters now with students, and it reveals so much more about what they're learning from the task than just asking them to tell me what methods they've used and so forth, right? So these 4 components are really important. So here's an example from Maisie. This is one of students, Michelle's students this year. So she ended up using this beautiful little
Good evening, my fellow Americans. We're facing an inflection point in history. One of those moments where the decisions we make today are going to determine the future for decades to come.
Okay, we won't show the whole thing there. But if you have a look here, she's gone through really carefully and considered, like, is this a suitable video or not? She's given some reasons that it's like staying kind of on it's a continuous shot, it's quite close up. But of course, there's considerations that this is an 80-year-old president. They might not be that representative, but she's had a little bit some studies around maybe there's a relationship between age and blinking. And at least she's like, one article I found at least says there's nothing really going on. And maybe the lighting involved, which is really cool too. I mean, this is a professional setup, this is a really important message that's being reported and sent out to the world. Maybe there's something to do with that. Again, she's thinking maybe the study's too old, and maybe it's to do with how much he's concentrating on what he's delivering. or reading off teleprompters. And so all of this is really cool, right? So this is all really interesting stuff. We know that we've seen this before when we ask students to, at the beginning of their kind of investigations, to really think about context as well. But this, of course, this is going to change depending on which of these different sources of data they might use to model eye blinks. You know, how the rest of the task works is then once Maisie went through and recorded every time Joe Biden blinked, she was able to look at that data. This is data from the true data generating process, and then she was able to set up a Poisson model and generate some data from that, and then see how they compare, right? So here's how they compare. So it's pretty similar. And then she's going to pull all those ideas together. And for this particular data source, you know, this particular source of data and her own exploration, she's able to come up with a good, well-reasoned conclusion there about, at least based on the data itself. She does talk elsewhere about having other concerns. For example, are eye blinks really independent from each other? Which is a key aspect of you know, using a probability model such as Poisson for this. So there's other aspects there, but you know, in the end, she's done a little exploration. She's her own data source, and she's created this adorable monster based on that. So it's pretty cool. And of course, that was monster blinks, but that whole kind of vibe could be anything. I've had students use a live webcam of the Abbey Road crossing. It's on all the time. It's actually hooked up a bit further back there, and then they've sat there and watched this video and watched, like, you know, people crossing Abbey Road, because it's a popular tourist spot. People take photos. It kind of causes a lot of traffic issues because the traffic always has to stop and put across. And so they watched this video and recorded it, and then that again is a bit of a challenge, because what does it mean to cross the road if you go this far or this far? You know, you have to make some decisions. But live webcams are pretty cool. On a personal note, you know, I've done it to myself. I've recorded how many times I say when I give talks like this or lectures, and it does come out to be fairly well compatible with the Poisson distribution. And then as soon as I start saying this, then I'm more conscious of using the word from now on. So anyway, I guess really quickly, let's just use the chat box at this point. Any other ideas of things that you've used in this sort of context? A source of data where students can go and choose it, they have to record from it, and then explore some sort of probability distribution with it. This is the idea of using things like hokey pokey pieces and ice cream or popcorns and those kinds of things, right? They're not necessarily new, but any other ideas you want to share, chuck them in the chat box now. Anything else you've tried out or could imagine trying out would be awesome to share. Oh, cool. M&Ms, what side they land on. Perfect. Are there two sides? Is the M&M only on one side? I didn't even know that. Yeah, that makes sense. Oh, cool. Yeah. And you know, creating a forest of trees that are trees that look natural. I got totally obsessed with the Pixar display at the Science Museum one time, because a lot of, you know, what they're doing when they're creating their graphics for their animations is to try to make things look real, right? And so they're trying to generate blades of grass, or you know, fish swimming, or forests. And yeah, what kind of sort of distribution or kind of process can you use to create realistic looking features in the world, which is pretty cool. Okay, so that's one aspect there, is to think about these tasks and think, well, if we got students collecting data, making choices about data sources, then that would help to embrace and promote creativity. Another way is to think of the task itself. So a lot of our tasks at the moment are kind of quite fixated on an answer, like an answer. So we might develop a probability model, but it's really used only for one time and to get one answer. So a classic example of this is some variation of the Freddy Freezes problem, right? So serial card collecting, or you know, the rugby card collecting, whatever it is, right? It's some variation on this where we set it up that there's so many symbols, and each of those has some sort of probability, and you set up a model, you generate data from it, and do a simulation, and then you kind of have to answer sort of maybe one question. So in this case here, if I was to run this using 10 days as the maximum number of days that Grace buys icebox for, with these kinds of weightings, when I ran it through, it came out to be like 8.4 days as a kind of an estimate there, and probably around about 51%, right? So how can we embrace creativity? Well, like I said, if we focus on the model itself more than just the answers, I think we can make some strides. So here is perhaps a way that you might be tackling this kind of task. Actually, in the chat box really quickly, is it like using Google Sheets or spreadsheets? That's what was kind of cool when I was at school before I left and moved to the university. Is that kind of a pretty common or popular way of doing this? I'm talking about sort of level 2 simulations. In the chat box, maybe just let me know. Are you using spreadsheets? Is that still the cool thing to do? Oh yeah, maybe using CodeF and Simmer as well. Perfect. I bring this up because I used to think that I do still think that using conditional formatting is actually pretty cool. Like it's like colorful and it's kind of helpful for when you're trying to work out when to end a trial, right? Because you can kind of spot the colors, and once you get one of each of the 4 colors, you know that it's kind of finished, and then you would need to stop it. The thing about this sort of setup in the spreadsheet is that it's kind of constraining, right? How I've set this one up, at least, is that I can generate which symbol it is using some formula, right? But in terms of when the trial ends, I have to go back and kind of myself manually decide when I've got one of each, and then kind of decide what that is there. And that's because kind of how this task is set up is kind of when we're thinking about, well, it is important to do things by hand and to map it out and have to have that experience, but it does constrain us if we want to be more creative and focus on models. It's not easy then, for example, to take a model that's been set up like this in the spreadsheet and then play around with it, right? And change some of the inputs for it and see what happens, right? Another thing that's also constraining about the setup is that in terms of the data that we want to use to make sense of this, is that we're going across, each trial is a row and we're going across the row, and we're structuring our data like this. And this is not this as a spreadsheet, as a data structure, is not really a very helpful data structure. Like if you were to pull in like columns A to K into any kind of software tool, it would be very difficult to use that data. And that's because we've organized it in a way where we're prioritizing each row as a trial. But what's really going on here is that each observation is part of a trial, and then we're kind of representing it in this format going across for the purposes of just trying to get an answer to one question. So it works for that purpose, but it's not very flexible and doesn't support a lot of creativity if we want to scale it up. So what are we doing? So we've got some sort of real world situation, this kind of Freddy Freezes competition. We know that what we're doing when we design simulations is we're trying to take a real world complex process, identify features of that process, simplify them. We are going to make sort of like compromises. It's not going to be an exact replication of what's going on. And particularly if we're looking at school level, there's obviously just what knowledge we're expecting students to use means we're going to make a lot of simplifications from what it really is. But what we really want to do is when we create this model is then learn from it, tinker with it, try things out and see what happens. So changing stuff and seeing what happens is kind of a vibe. All right, so what if, for example, we wanted to know what would happen if she had only enough for 5 days? What if she had enough for 20 days? What if there was no limit? What if there were less symbols to collect? What if the symbols had the same properties? There's so many possibilities here. At the moment, we can't explore these as sort of creative outlets for this particular question, because how it's set up and the sort of technology we're using doesn't support it. And the sort of general idea here in terms of generalizations, right, would be, well, how does Grace's chances of winning a prize change as the number of days she buys icebox for increases? Right? Now, we don't need to do that mathematically initially, but it would be great if we were in an environment where we could generate data and learn from that. So I, in my PhD research, was looking at a sort of a way of approaching task designs. And I'm bringing this up now only because I am about to show you some code, but I want to preface it by saying I wouldn't normally jump into where we are, but just for the like how much time we have in this talk. But initially what we'd be doing is we'd be immersing ourselves in the modeling, so for example, doing simulations by hand, experiencing it on a smaller scale, really thinking about what the key actions are that we're doing with our modeling with Unplugged or some GUI tools, and then matching it to particular ways that we could do the same things with code, leading to the point here where we are able to adapt code and then use code for exploration, right? And in particular here, that our kind of overall learning goal for this is some sort of computational product. So what I was saying before is like our goal should be like to create a model and then use that model to explore. That's what we want to try to have as our actual learning goal for a particular task if we're thinking about statistical modeling and also embracing data technologies. So I'm going to open this up for you. And again, this is not where I would start, but it is where I'm going to jump into you and show you just to kind of, I guess, sort of paint the scene in terms of how much easier it would be to do exploration if we had a way to communicate and articulate our model that students could engage with, and we had an environment where we could see what happens with that data, right? Which we don't really have easily in the spreadsheet format. So I'm not going to go into the details of it too much, but the setup here is basically those are the 4 different symbols that we have. Those are the weightings that we've been told that we have. In this case here, these one of our conditions might be for our simulation that those stay the same. And we do make that assumption in the level 2 task because of we have to, right? Just to make it an easier version of a simulation. What's tricky about this particular modeling task actually are those stock rules, because we have 2 ways that the trial ends. Either we have 10, we've brought the icebox for 10 days, or we get a set, which means that the values that we have, if we look at how many unique values we have and count that up, that we've got 4. And as soon as we get 4 that are different, we can stop, right? And so what this shows you here is a very similar result to what I showed you before, where I've run it under the initial conditions, which is that we're going to stop after 10 days or when a full set is found. And all I've done here is I've said, well, I'm going to try out different versions. This is the version that you have when we use 10, right? If I change that to a version where we only have 5 days, then that means that we can run that through. And again, our focus is on what can we learn when we change our parameters. So we'll just change that. The model's the same. We've changed our kind of parameters for it. And we can see, as we would expect, your chances of a prize goes down. Here, I haven't actually got that set up. Hold on for a second. If I just drag that over. And I just need to make that categorical. There we go. So here we can see, of course, as you would expect, if you're only going to do 5 days, obviously, once you get to 5 days, you tap out, right? And so that's going to change the distribution quite a lot. But if we scale it up to 20 days, because we can do that, because we have our model in a format where we can play with it, we can tinker with it, we can generate data with it. If we do that now, again, as you would expect to see, that we're going to see that the probability of a prize is now increased up to 84%, so forth, and we can see the distribution has changed, right? And then what we can do is we can take the data, that is how many days I've collected data for, and we can plot it against our success of winning a prize, right? And then from that we can get this generalization of how this sort of set up this model, how does the probability of a prize change as you increase the days, right? And that is cool. and it allows the students to explore their own what if questions as well, right? You can change any aspect of this and see what happens. And if you have that in mind, if you have that as a focus, then if you think about the kinds of ways that we could be doing tasks, then it could be something more like this. You get to create your own version of a competition. You come up with the rules. Who do you want to use? Maybe an existing company, maybe a fictional one. It's up to you how many cards, maybe between 6 and 10. I found with these kinds of tasks, you need some sort of like guidelines or boundaries, right? Just to keep it a little bit framed in. And this is cool. You want 2 prizes now. So you want one that like 90%, over 90% of students could, 90% of customers could get, right? So like a kind of an easy prize, but then you also want the one that's hard, right? So no more than 20% could get if they collected 20 cards. And then it's up to you to come up with what kind of scenario of how many cards and weightings is going to help you achieve this sort of distribution of prizes, right? So this is an activity I tried out with my teachers as part of my PhD research, and they really enjoyed it. I didn't actually have the tool I had that I just showed you before, would have made it easier, but that's what happens with research. You try things out, you put it in front of people, and you realize, oh, actually, it would have been better if they had a better environment to do that activity. But the thing that was really great about it was seeing the combination of knowledge and creativity and communication as they grappled with this idea and came up with different solutions or different creations for different competitions that still met this brief. So one last thing to focus on is a really quick one, which is that those two examples, I specifically chose things that are currently assessed, in our curriculum at year 12 and year 13. So probably distributions and simulations at level 2. But there's a whole bunch of creativity that we can explore through generating text, right? This video here is, I'll just show you a little bit from it.
1 and 8 for the adjective and 1 through 8 for the noun, and that is the box or LEDs that will line up. So basically all we have to do is assemble all of the LEDs into here, count which numbers line up with which box, reprogram this little brain right here, and then this is gonna be done.
My apologies, it skipped past the bit that actually told you what they were doing, which is right back at the beginning here. Hold on, here we go.
A, then it'll be a series of 8 positive, wholesome adjectives, 8 positive, wholesome nouns. Some of them we came up with, some of them our patrons came up with. One of the nouns is potato, so that one's not really like a compliment, but we thought it was funny.
It's funny. And then at the very front, we need to have some way to diffuse the light and to hide the words that aren't active at the moment, the words that aren't lit from behind.
So the premise of it, sorry, my editing of that video, I did put in like where it started and where it ended, but I think I got them mixed up. But the premise of it is that it's to create random motivational phrases where it always starts off with you are, and then you randomly choose an adjective and then randomly choose a noun. So I saw this video a few years ago and turned it into a creative task. And does it have connection to the true kind of daydreaming process? Not really, it's mostly for lols. It's just a way to have fun with creating something with a probability model. And again, jumping into the kind of ends of things, what I'm about to show you comes at the end of a progression where students have been familiar with the idea of how to take a sample, how to use some basic ideas of coding. But when we jump into it, and I'm just looking at the time here, so I'm going to show it to you, which I'm very sad about because it's actually kind of a lot of fun, but I'll show you what it looks like, is that they are able to here with some adjectives and some nouns and a little bit of code that does a nice pretty box, is go through and create their own random motivational phrases, right? And how this works is that, yes, they've got some code to begin with, and then what they have to do is go through and they can change their adjectives to be what they want, the nouns to be what they want. They can change the colors, the fonts, where the text sits, all those kinds of things. And through that process, they're generating data from a probability model. And you might think, well, what are they learning from it? Well, they learn a lot. I always get questions from students who are like, I think the code's broken. I'm like, why do you think the code's broken? I was like, well, it generated the same phrase like 3 times. I'm like, well, is it only generating those 3 phrases? No. It's just like sometimes I'll get like two or maybe 3 in a row are the same. I'm like, no, that's fine. That is actually what we also expect, when we generate data from a process. So related explorations to this idea of generating text might be, can you come up with a strategy to find unlisted videos on YouTube? They're made up of a particular combination of letters and digits and some symbols. Not only can you find a strategy for doing that, but how likely is your strategy to work to find a public YouTube video? Another thing is to do with like how we might generate usernames. We could generate them, how usernames are currently generated are by using people's names, like the first letter of their first name and the first 3 letters of their last name. But would it be more or less risky to generate usernames using 4 random letters? Now, I love these ones because it's risky. If you think about generating 4-letter words with letters, and you're thinking, how do you quantify risky? But it's also risky if you think about other languages as well. my view is very, you know, kind of English centric, right? Because I'm looking at the words that are being spelled in English. But if we widen it up to other languages, there's other risky versions of usernames that you might generate if you're not careful with that as well. So I was going to do this talk actually about using these probability models to generate standards, names of NCA standards, by taking all the ones that exist. There's like 20-something thousand of them. A lot of work went into, like, you know, naming those standards. But learning data, using data from the past, using probability models, it's a Markov chain, and generating text from that. You can see that this came up demonstrating understanding of art and data, which is probably pretty appropriate for a talk about creativity. But this is also another way that we can step students a bit forward, and using probability models is to think about generative text as well. Anyway, thank you all very much. I rushed through a few of those things at the end, but I have given a bunch of links here which elaborate on some of the things I touched on as well. But thank you all so much.
Thank you, Anna.